I am here for discussing open sets and closed sets in 1, 2, and 3 space. Basically, this discussion will help you to understand topology and space. So let's start the discussion on open sets, open sets, open sets, open and closed sets, closed sets in 1, 2, and 3 space. 3 space. So first of all, we are going to discuss these sets open and closed in one space. In one space. In that case, we can consider only one line, which is a real line. We consider a real line, that is, we are in single dimension. So here we consider uh, an open interval, that is such type of interval which is from A to B, and we denote this set by S, that is S equal A to B open interval. Here, this interval contains in between the points A and B, excluding A and B. Here, A and B do not contain this interval. So, by definition of open set, we know that empty set is an open set, but this set is not empty. So, leave this conception of empty set. And again, we know that a set which is subset of real number is said to be open if it is a neighborhood of each of its points. So we'll have to check the neighborhood of such points which lie on this set. Let uh, uh, an arbitrary number of these sets or elements of this set is x naught. If we make a neighborhood around x naught, we will get such type of interval, which is denoted by x naught minus epsilon to x naught plus epsilon. And we clearly see that this interval lies on this open interval. This new interval x naught minus epsilon to x naught plus epsilon lies on this open interval A to B. And it is true for all elements in between points A and B. That is, we can say that this open interval is the neighborhood of each of its points. That is why this interval is called an open set. This interval is called an open set. In another definitions, or in another words, we can say that, or we know that a set is said to be open if every point of this set is an interior point of this set. So here also we see that every point of this open interval is an interior point of this set. That is why this set is called an open set. So we can conclude that in one space, open set is an open interval. Therefore, this interval lies on A to B. So S is neighborhood of x naught. Here, therefore, S is open. Uh, so we can say that in one space, open set, is an open interval. This is the conception of open set in one space. Now we'll try to discuss closed set in one space. For this, we can consider a same interval including the points A and B. That is, we consider closed set which contains in between points of A and B, including A and B. In that case, we will have to check the complement of S. If complement of S is open, then by definition we can say that S is closed set. So we have to consider the complement of S. Here, the complement of S. The complement of S, which is made by such symbol, equal to all real number except the elements of S. So we clearly here observe that this set contains a minus infinity to A. A is open as because A is included here. That is, as complement exclude A and exclude B. Again, union B to infinity. So follow, dear students. Here the characteristics of S complement. S complement contains two intervals which are open, minus infinity to A and B to infinity. We know that any open interval is an open set. So minus infinity to A is an open set. Also, B to infinity is an open set. And we know a theorem, the union of two open sets is also an open set. So we can say that S complement is an open set, which is open. Since S complement is open, so by definition we can say that S is closed set. Therefore, that is S is closed. So we say that here S is an open set and S is an closed set. Here S is a closed interval. So in one space we can say that closed set is nothing but a closed interval. Therefore, closed set is closed interval. Mind it, open set is an open interval, but closed set is a closed interval. This is the conception of closed set into space. Dear students, please concentrate on a logic which will help to understand the other two space, that is 2 and 3 space for open sets and closed sets. We know another definition of closed set is if S is closed, then S is closed, then it contains all of its limit points. So we can say that closed set equal to set of limiting points. Sorry. In some cases, closed set equal to set of limit points. And which are limit points? Limit points are interior points, interior points, and boundary points. Boundary points. And we see here S contains interior points from A to B and boundary points A and B. So in some cases we can say that closed set can be made by all interior points and boundary points. And we see here this region contains all interior points in between A and B and include its the point in points or boundary points A and B. This will help us to understand the next two space for open sets and closed sets. Now we are going to discuss these sets in two space. In two space. In two space, actually, we are on two-dimensional plane. Now, if we take a region on this plane bounded by this circular path, we see here this circular region contains some boundary points which are marked by red points, and inside these points are denoted by black points. So follow the student. This region or this circular disk contains many points which are included in interior position, and these are black points. Also, this region contains the boundary points which are marked by red points. Since we know that open set is such a set which contains only interior points. So we can easily say that in two space, the open set is a open disk. This circular disk is made by some boundary points and some interior points. We know that open set contains only interior points. So we can say that into space, open set is a is an open disk. Open disk. Again, since we saw in previous example or previous section, we said that a closed set made by interior points and boundary points. So closed set contains all interior points along with these boundary points. So we can easily say that in two space, closed set is a closed disk. Closed disk. So in two spaces, open set is an open disk and closed set is a closed disk. This disk contains only black point, but this set contains black points plus red points. So the combination of black points and red points we can make closed set. But by only black points we can make open set. At the end, we are going to discuss these two sets in three space. In three space. So these are actually a similar discussion. For three space, actually we are in a space, three-dimensional space. So in that case, we can consider a sphere like this. These red points are boundary points of this sphere we can consider, and the inside point can be considered by black points. Red points are surface point or boundary point, and black points are interior points of this set. Now, if we consider the neighborhood of surface point or boundary point, let this point can be denoted by x naught. Now, if we make a neighborhood like such, we clearly see that there many points are there which are not included in this set S. This set is denoted by say S. So we can say that S is not neighborhood of all boundary points. Since S is not neighborhood of boundary points, so including boundary points, we cannot say that S is an open set. But S is or S will be a neighborhood of all other points which are situated in interior position. Let this point is denoted by y naught. So we can easily say that S is a neighborhood of y naught. That is, it is valid for all interior points of this sphere. So we can say that in three space, open set is all interior points of this sphere. That is, in three space, in three space, in three space, open set is an open ball. Open ball. Again, if we know that the closed set contains all interior points and boundary points, so we can easily here say that closed set is a closed ball. That is, entire sphere is considered as a closed set. So, in three space, closed set is closed ball. So it is very simple. In three space, open set is an open ball and closed set is closed ball. That is entire sphere. All these interior points as well as the boundary points are included in closed sets. So dear students, this was my today's effort to help you. Thanking you very much.